this video, I'm going to walk you through the post-lab for lab 4 real versus ideal gases. So the first data table on this is data for an ideal gas number 1. You will have reported the volume for the gas under these 4 different combinations of pressure, temperature, and moles, and then you're going to use that to calculate the value of R. Notice that the question is asking you to report the value of R to 6 decimal places, so that's going to be a lot of sig figs. And to do this calculation, you'll be using PV equals nRT, and you'll just simply be solving for R. So that means we're going to say R is given to us by taking the pressure times the volume, dividing by the number of moles, dividing by the temperature, and everything is in the right unit. The pressure is in atmospheres, the volume is in liters, the moles are in moles, the temperature is in Kelvin. So for this, it's just a matter of plugging in your pressure, your volume, your moles, and your temperature and calculating R. Because this is an ideal gas, these numbers should be coming close to the textbook value of R. And then down here, you're going to calculate the average value of these 4 values of R. So that's just your mathematical average. You're going to add all of them up and divide by 4 and get this number here. Then you'll be calculating the percent error for your experimentally determined value of R. You're going to plug in your average value, which you calculated right here, and you're going to subtract the standard value to 6 decimal places. It's 0.082057. You'll divide by the standard value, which is right here, multiply by 100, and typically you get some pretty low percent error. This normally gives some pretty good data. So if your percent error is super high, or if you're getting values that aren't close to the standard value of R, maybe just double check your math, or maybe double check some of these measurements that you made. So then next, you're going to be basically repeating the experiment using a non-ideal gas. First, you'll be using methane, CH4. Same type of thing. You're going to take that sample of methane under 4 different situations, and you'll be reporting the volume under each of these 4 situations. For each one of these, you'll be calculating the value of R again, and for that, again, we're using PV equals nRT. So that's going to be R equals PV over NT. Same thing, plugging in these different pressure, temperature, mole, and volume combinations. Because this is not an ideal gas, this is methane, you're going to see more variation in these values of R, meaning that this value of R might not be the same as the next one or the one after that. There'll be, some fluctuation here. So notice that you're not being asked to calculate the average this time, because you'll see quite a bit of variation in these numbers. And then, looks like I got some kind of typo because it's saying to do the same thing again for CH4. So let's kind of look back and see what it's supposed to be. Looks like it's supposed to be CO2 instead of CH4. I don't know why I made that mistake. So we'll just kind of fix that. This is going to be for CO2. So you're going to be repeating the experiment with another real gas, carbon dioxide, CO2. 4 different combinations of pressure, temperature, and moles. You'll report the volumes for all of those, and then again, calculate the value of R using this equation, R equals PV over NT. And again, because this is a real gas, not an ideal gas, you're going to see some fluctuation in these numbers. You're not going to be calculating the average value. So the last part of the lab is where things get a little bit tricky. It's asking you to analyze the experimentally determined value of R, determined values of R, for the data sets for methane and CO2, and complete the following statements. The first one is asking for you to look for the least accurate value of R and to figure out whether this is coming from high or low pressure and high or low temperature. So what you're going to do, we'll just start by focusing on your CH4 data. You're going to look at these 4 values and you're going to determine which one is the least accurate. Assuming that the standard value of R is 0.0820, let's see, I got to look back to all those sig figs, 57. So what you're doing here is looking for the value of R that is the furthest away from this expected value. That will be your least accurate value. And then you're going to determine if that value, that least accurate value, corresponds to high or low pressure or high or low temperature. So to figure that out, you'll be looking at the pressure and temperature data. So let's just say, hypothetically, let's just say that this is our worst value of R right here. Like that's the worst value that we can come up with. And if we're looking at the pressures for that terrible value of R, we can see that we obtained that terrible value of R when we were operating at a high pressure. So this is a high pressure, and 1 would be our low pressure. And then we can do the same sort of thing with our temperature. So for this, we're saying that this is our worst value of R. This, we're comparing 160 versus 400. 400 is our high temperature, and 160 is our low temperature. So if this was our data and this was the worst value of R, we would say that that corresponded to high pressure, low temperature. For your CO2, you should come up with the same result. So if this was the worst value of R for your methane, you should get the same thing in terms of this being the worst value of R for your CO2. And then you're just going to circle the appropriate boxes, or circle the appropriate words. Then you're going to answer similar question, the most accurate value of R. So now what you're looking for is the number that matches most closely with 0.08205. You'll figure out which one that is. Maybe it's this guy right here. And you'll take a look at what pressure temperature combination gives you that very accurate value. This, because I've just randomly picked this is a high pressure and high temperature. So that's how I would answer this question. I would say the most accurate value of R comes from high pressure, high temperature. Now again, I'm just randomly drawing smiley and frowny faces. It's not necessarily what your data is going to look like. You'll just have to see for yourself. Then, based on your answers to question 6, we're going to answer question 7. A real gas, so that's going to be, in this case, the methane, CH4, and the CO2 gas, deviates from ideal behavior when it is at high or low temperature. So deviating from ideal behavior, that is reflected by having an R value that is very different from our standard 0.082057. So if it's deviating from ideal behavior, that's going to be reflected by this R value being calculated to be very different from what we would expect it to be. So we're looking for, in this case, deviation, which corresponds to the least accurate R value. So whatever you've circled here, that's what you're going to circle down here, and the same thing for this. A real gas exhibits near ideal behavior, so that means R is very close or very similar to our expected value of 0.082057. And so again, that would mean the most accurate value of R, near ideal behavior. What pressure do you see? What temperature do you see?